Okay, so hello and welcome back. So question number 8, you want to find, let me give myself a little bit of space here. Okay, so question number 8, you want to find x. Want to find x if y is equal to 3214 and 2x plus y is equal to 10 negative 32. Okay, so I can write the equation as basically I can write it as 2x plus y and subtract the y here and write it as basically 10 negative 32 negative 32 and negative 32 and subtract the y from here. Then y minus y is equal to O, so then you can write 2x plus O is equal to 10 negative 32 minus y. 2x plus O is equal to 2x, so 2x is equal to 10 negative 32 minus y, and then divide by 2, you will get x is equal to 1/2 times 10 negative 32 minus y, and y is equal to, we said that y is equal to basically 3214, so x is equal to 1/2 times 10 negative 32 minus y, which is equal to 3214, which is equal to, so x is equal to 1/2 times 1 minus 3 is equal to negative 2. We write it this way. So you have 1 minus 3 is equal to negative 2, negative 2, negative 3 minus 1 is equal to negative 4, and negative 2 minus 4 is equal to negative 2. So x is equal to basically negative 1, negative 1, negative 2, and negative 1. So that is basically your x. Question number 8. Question number 9. Question number 9, you have find x and y. Question number 9, you have find x and y if 2 times 130x plus y012 is equal to 5618. So if I multiply this 2 by this matrix, I'll get 2602x plus y012 is equal to 5618. And then if I add these together, I'll get 2 plus y, 6, and then 0 plus 1 is equal to 1, and 2x plus 2 is equal to 5618. And then you have 2 plus y is equal to 5, which means that y is equal to 3, and you have 2x plus 2 is equal to 8, which means that 2x is equal to 6 and x is equal to 3. So x is equal to 3 and y is equal to 3. That was question number 9. Now question number 10. You want to solve the equation for xyz. Solve for xyz and t if basically 2 times xzyt is equal to 2 times xy is actually, this is number 10, so xdyt is plus 3 times 1 negative 1 0 2 is equal to 3 times 3 5 4 6. Multiplying 2 by this matrix, I will get 2x, 2z, 2y, and 2t. Multiplying 3 by this matrix, I will get 3, negative 3, 0, and 6. And multiplying 3 by this matrix, I'll get 9, 15, 12, and 18. Adding these two together, I'll get 2x plus 3, 2z minus 3, 2y, and 2t plus 6 is equal to 9, 15, 12, and 18. And then I can write 2x plus 3 is equal to 9, meaning that 2x is equal to 9 minus 3 is equal to 6, meaning that x is equal to 6 by 2, which is equal to 3. And then 2y is equal to 12, that means that y is equal to 6. And then 2z minus 3 is equal to 15, meaning that 2z is equal to 15 minus 3 is equal to 12, meaning that z is equal to 6. And then you have 2t plus 6 is equal to 18, meaning that 2t is equal to 18 minus 6 is equal to 12, meaning that t is equal to 6. That is the values for, that means that x is equal to 3, y is equal to 6, z is equal to 6, and it seems that z is supposed to be equal to 9 and t is equal to 6. So 2z minus 3 is equal to 15. That means that 2z is equal to 15 plus 3. I'm sorry, I made a mistake here. I did make a mistake here. Okay, so 2z is equal to 15 plus 3 is equal to 18, meaning that z is equal to 9. Okay, that was question number 10. Question number 11 is find, if you want to find the values of x and y. So x times 2, 3 plus y times negative 1, 1 is equal to 10, 5. Is equal to 10, 5. So multiplying x here, you'll get 2x, 3x. And multiplying y over there, you'll get negative y and y is equal to 10 and 5. Adding these two together, you'll get 2x minus y and 3x plus y is equal to 10 and 5, which means that 2x minus y is equal to 10 and 3x plus y is equal to 5. This is a system of equations. If I add them together, y's cancel out. 5x is equal to 15. That means that, meaning that x is equal to 3. Since x is equal to 3, I can pick, for example, this equation. 2 times 3 minus y is equal to 10, meaning that 6 minus y is equal to 10, meaning that negative y is equal to 10 minus 6, which is equal to 4, meaning that y is equal to negative 4. So x is equal to 3 and y is equal to negative 4. That was question number 11. Question number 12. You have 3 times xyzw is equal to x 6 negative 1 2w plus 4 x plus y z plus w and 3. Multiplying these 3 by this matrix, you'll get 3x, 3y, 3z, 3w, and adding these two together, you'll get x plus 4, 6 plus x plus y, z plus w minus 1, and 2w plus 3. Meaning that 3x is equal to x plus 4, 3x minus x is equal to 4, so 2x is equal to 4, and x is equal to 2. Then 3y is equal to 6 plus x plus y, x is equal to 2, therefore 3y is equal to 6 plus 2 plus y, 3y is equal to 8 plus y, and 3y minus y is equal to 8, so 2y is equal to 8, meaning that y is equal to 4. Next you have 3z is equal to z plus w minus 1. Which I cannot solve right now because I don't know what w is. I have to first solve for w. So I solve for w here. 3w is equal to 2w plus 1. I'm sorry, plus 3. So 3w minus 2w is equal to 3. So w is equal to 3. Now 3z minus z is equal to w is equal to 3 minus 1 is equal to 2. 2z is equal to 2 and z is equal to 1. Means that x is equal to, this was number 12, x is equal to 2, y is equal to 4, w is equal to 3, and z is equal to 1. So, question number 13. Question number 13. You have, if basically f of x is equal to this matrix of cos of x, negative sine x, 0, sine x, cos x, 0, 0, 0, 1, right? If that is the case, you want to show that f of x times f of y, f of x times f of y times f of y is equal to f of x plus y. think I don't understand what is meant by this. What is meant by f of y? Let me check the solution. Okay, so what they mean by this expression, which is something very simple, I didn't actually see it. When you say f of x is equal to basically this matrix, then that means that basically f of y becomes basically cos of y instead of cos of x, of course. Then negative sine of y, 0 constants are constants, so they don't change. Sine y, cos y, and 0 and 0, 0, 1. Right, so that is basically what they mean by this. And so basically then the LHS of this becomes f of x is equal to f of x times f of y, f of x times f of y, which is equal to cos x negative sine x 0 sine x cos x 0 0 0 1, and then f of y is basically this matrix here, which is cos y negative sine y 0 sine y cos y 0 0 0 1, and if you multiply these together, you can go this row, this column. What you will get is basically a matrix of, this is 3 by 3 by 3, 3 by 3, so you get a 3 by 3 matrix. So you have cos x times cos y, cos x cos y, and negative sine x sine y, and then 0 times 0 is equal to 0, right? Then the same row, this column gives you negative cos x sine y, negative cos x sine y, cos x sine y, and negative sine x cos y, negative sine x cos y, and then you have a 0 over here, which is just a 0, and then the same thing over here is the same row, this column gives you basically 0 0 and 0. That's just a 0. Then you can move to this row and this column. You have sine x cos y, sine x cos y, plus cos x sine y, cos x sine y, and then you have a 0 there. Then the next column is going to give you negative sine squared, negative sine x sine y, negative sine x sine y, and basically cos x cos y plus cos x cos y, and this is a 0, and then moving to this column you will have 0 and 0 and 0. That would give you a 0, and then this row times, you can go for this row and this column, 0 0 0, so that gives you just a 0, and moving to this column 0 0 0, that would be a 0, and this column would give you 0 0 and 1, and so you have this matrix, and that is equal to, now cos x cos y minus sin x sin y is the same thing as cos of x plus y, right? That is the same thing as cos of x plus y, I suppose, right? Because cos of x plus y is equal to cos x cos y minus sin x sin y, right? So this is the same thing as cos of x plus y. Next, this one, basically cos x sin y, sin x, you can write this as take a negative out and write this as negative of sin x cos y plus cos x sin y. And that is negative of sine of x plus y. And negative of sine of x plus y is the same thing as actually that's not supposed to happen. Well, the negative sign, you already have it here, so that's not a problem. So that's negative of sine of x plus y, right? And that's a 0, so that we have no problem there. And over here you have sine x cos y plus cos x sin y, so that's the same thing as sine of x plus y. Over here you have cos x cos y minus sine x sin y, that's cos of x plus y. So then I can write this matrix as basically cos of x plus y, and then negative sine of x plus y, then you have 0, then you have sine of x plus y, then you have cos of x plus y, then you have 0, 0, 0, and 1, and that gives you, and that is actually equal to, so you can see that over here f of x was basically this matrix, right? And based on this matrix, if I want to write f of x plus y, if I want to write f of x plus y, it gives me basically cos of x plus y and negative sine of x plus y, then that's a 0 sine of x plus y and cos of x plus y, and 0, 0, 0, 1, right? So that would be f of x plus y, and if you compare, you will get exactly the same thing here, which means that this is the same thing as f of x plus y, right? Which means that basically, which means that f of x times f of y, which means that f of x times f of y is equal to f of x plus y. That is what we wanted to show. So that was question number 13. Now, question number 14. Question number 14, we have question number 14, we want to show that, for example, 5, negative 1, 5, negative 1, 6, 7, this matrix times another matrix 2, 1, 3, 4, 2, 1, 3, 4 is not the same thing as 2, 1, 3, 4 times 5, negative 1, 6, 7. So this is 5, negative 1, 6, 7, 5, negative 1, 6, 7, 2, 1, 3, 4, 2, 1, 3, 4, meaning that you want to show that A times B is not the same thing as B times A, right? So if I calculate, meaning that in matrix multiplication is not commutative. So if I calculate the LHS of this, of the equation, I have 5, negative 1, 6, 7, and you have times 2, 1, 3, 4. That is equal to basically, so this row and this column, so 5 times 2 is equal to 10 plus negative 3, and then you have 5 times 5 and negative 4 plus negative 4, and then you can write this as 6 times 2 is equal to 12 and 7 times 3 is equal to 21, and then this column would be 6 plus 28. So that is the same thing as basically 10 minus 3 is equal to 7, 5 minus 4 is equal to 1, 12 plus 21 is equal to 33, and 28 plus 6 is equal to 34, right? Is equal to 34. So that is basically that is equal to your LHS. Now if I write 2, 1, 3, 4 and multiply it by 5, negative 1, 6, 7, I will have basically this row and this column. I will have 2 times 12 is equal to 10 plus 1 times 6 is equal to 6. The next column, 2 times negative 1 is equal to negative 2, 1 times 7 is equal to 7. And then I have this row times this column. I have 3 times 12 is equal to 15, and 4 times 6 is equal to 24. And this column I have negative 3 plus 28, which is equal to basically 16. 5, 24 plus 15 is equal to 39, and 28 minus 3 is equal to 25, and that is equal to your RHS, and therefore LHS is not equal to RHS, meaning that in matrix multiplication is not commutative. Also you want to show that basically 1, 2, 3, 0, 1, 0, 1, 1, 0 times negative 1, 1, 0, 0, negative 1, 1, and 2, 3, 4, and 2, 3, 4. You want to show that this is not equal to negative 1, the same matrix basically, negative 1, 1, 0, 0, negative 1, 1, 2, 3, 4, times 1, 2, 3, 0, 1, 0, 1, 1, 0, which is basically the same matrix that we have here. Now if you start with the LHS, you have you have basically 1, 2, 3, 0, 1, 0, 1, 1, 0, and multiply it by this matrix negative 1, 1, 0, 0, negative 1, 1, 2, 3, 4. And well, as long as we are, I think we have determinants in this chapter as well, so I'm not going to, otherwise I would not write these. Okay, so I will start with this row, with this column, and write this as basically 1 times negative 1 is equal to negative 1, and 2 times 0 is equal to 0, and 3 times 2 is equal to 6. Then this column, you have 1 times 1 is equal to 1, and 2 times negative 1 is equal to negative 2, and 3 times 3 is equal to 9. And this column, you have 1 times 0 is equal to 0, 2 times 2 is equal to 2, and 3 times 4 is equal to 12. The next row, we have, and this column, 0 plus 0 plus 0 plus 0 plus 0. And then this column, you have 0 plus negative 1 plus 0. And this column, 0 plus 1 plus 0. And then you have this row and this column, so negative 1 plus 0 plus 2 plus 0. Then coming to this column, you have 1 plus negative 1 plus 0. And coming to this column, you have 0 plus 1 plus 0. Now adding these together, you will get 6 minus 1 is equal to 5, 9 minus 2 is equal to 7, plus 1 is equal to 8, and 12 plus 2 is equal to 14. That's a 0, that's a negative 1, that's a 1. Then you have a negative 1, then you have a 0 here, and then you have a 1 there. And that is basically your LHS. Now your RHS is the same multiplication but in the reverse order, meaning that basically you can write basically negative 1, 1, 0, 0, negative 1, 1, and 2, 3, and 4. And that times basically 1, 2, 3, 0, 1, 0, 1, 1, 0. Okay, so now basically the same multiplication in the reverse order, 1, 2, 3, and so on and so forth. So if I do this multiplication, I will have basically this row, this column, which is negative 1 times 1 is equal to negative 1, plus 1 times 0 is equal to 0, 0 times anything is 0, and going to this column you have negative 2 plus 1 plus 0 plus 1 plus 0. This column you have negative 3 plus 0 plus 0. And the next column, the next row, basically, in this column you have 0, 0, and 1. 0 plus 0 plus 1. And this column you have 0, negative 1 and 1. 0, negative 1 and 1. And this column you have 0, 0, 0. 0 plus 0 plus 0. The next row over here you have 2, 0 and 4. You have 2, 0 and 4. 2 plus 0 plus 4. And then you have 4 plus 3 plus 4. 4 plus 3 plus 4. And then you have 6 plus 0 plus 0. And adding these together, you will get basically negative 1, negative 1, negative 3, 1, 0, 0, 4 plus 2 is equal to 6, 8 plus 3 is equal to 11, and 6, and that is equal to your RHS. And as you can see, well, they are not the same matrices, which means that your RHS is not equal to your LHS, which means that matrix multiplication is not, of course, commuted. So that was question number 15. Now question number 16 is another question. You have, suppose that A is equal to, I need a little bit more space here because this is a little bit too 6. Okay, so if A is equal to, this is question number 16, and A is a matrix 1, 0, 2, 1, 0, 2, and you have 0, 2, 1, 0, 2, 2, 1, you have 2, 0, 3. This is the matrix A that we have. And then you want to prove that A cubed minus 6A squared plus 7A plus 2I plus 7A plus 2I is equal to O. Now, here what we can do is that first let's calculate A cube. I want to check something here. So to calculate A cube, I first calculate A squared, which is equal to A times A, which is equal to 1, 0, 2, 0, 2, 1, and 2, 0, 3, because I want to see if something actually works. And 1, 0, 2, 0, 2, 1, 2, 0, 3 times the same matrix, and that gives me now this column gives me 1 plus 0 plus 4, and this column gives me a 0, 0, 0, and this column gives me 2, 0, 6. 2, 0, 6. Now the next row, you have 0, 0, 0, and 2. 0, 0, and 2. This column gives me 0, 4, 0. 0, 4, 0. This gives me 0, 2, 3. 0, 2, and 3. This column, this row, and this column gives me 2, 0, 6. 2, 0, 6. This column gives me 0, 0, 0. 0, 0, 0. This column gives me 4, 0, 9. 4, 0, 9. And adding these together gives us basically 1 plus 4 is equal to 5, 0, 8, 2, 4, 5, 8, 0, and 13. Now this matrix is A squared. Now since I need to calculate A cube, I can write A cube as A squared times A, or I can write it as A times A squared. Now we will calculate both of them and see what happens. Okay, most probably they're going to be the same, and I don't really know why this happens. They're not, I mean, matrix multiplication is not necessarily commutative, but it seems that when you're using the same matrix but to multiply it by itself over and over again, then what happens is that if you write A squared times A is going to be the same thing as A squared times A all the time. It doesn't change it. Or let's see if it does or if it doesn't. So I'm going to calculate A squared times A first, and then we will swap it around, see what happens. So A squared times A is going to give me 5, 0, 8, 2, 4, 5, 8, 0, 13, and multiply this by A, which is basically this matrix 1, 0, 2, 0, 2, 1, 2, 0, 3, and 0, 2, 1, 2, 0, 3, and so that gives me this row, this column gives me 5, 0, 16. 5, 0, 16. This column gives me 0, 0, 0. 0, 0, 0. This column gives me 10, 0, 24. 10, 0, 24. This row and this column gives me 2, 0, and 10. 2, 0, 10. 2, 0, and 10. 2, 0, and 10. This column gives me 0, 8, 0. 0, 8, 0. This column gives me 4, 4, and 15, right? 2 times 2 is equal to 4, and 4 times 1 is equal to 4, and 5 times 3 is equal to 15. And 8, 0, 26. 8, 0, 26. And 0, where am I right now? Right here, right? So 0, 0, and 0. 0, 0, and 0. And here you have 16, 0, and 39. 16, 0, 39. So that is the matrix that we have. And let's add this together and see what we get. So that's equal to basically 5 plus 16 is equal to 21. That's 0. 10 plus 24 is equal to 34. 2 plus 10 is equal to 12. That's an 8. That's 8 plus 15 is equal to 23. 8 plus 26 is equal to 34. And 0. And 39 plus 16 is equal to 49. 49 plus 59. 59 minus 4 is equal to 55, I suppose, right? 39 plus 16 is equal to 15, 1. It's 55, right? Okay, so that is the matrix that we have, and that is the same thing as a squared times a. Now, what is a times a squared? What is a times a squared? A times a squared is the same thing as this basically the other way around, meaning that 1, 0, 2, 0, 2, 1, 2, 0, 3, and times a squared, which is basically 5, 0, 8, and 2, 4, 5, and 8, 0, 13. And and if I do this multiplication, what I will get is basically this row, this column, so it gives me 5, 0, 16, 5, 0, 16, and this column gives me 0, 0, 0, 0, 0, 0. This column gives me 8, 0, 26, 8, 0, 26. Seems that it's different. No, they're not actually different. It's 10 plus 20, 10 plus 24 is equal to 34, and that is again 34. Okay. So now this row, this column gives me 0, 4, and 8. 0, 4, and 8. And then over here you have 0, 8, and 0. 0, 8, and 0. And over here you have basically 0, 10, 10, 13. 0, 10, 13. Over here you have, so this was right here, so this one and this one, 0 and 10 and 13, right? So you have 2 times 12 is equal to 10, 0 and 24, and then you have come to this column, you have 0, 0, 0, and then coming to this column you have basically 16, 0, 39. 16, 0, 39. Maybe if you want to know why that works, you have to pay attention to how matrix multiplication, basically the process is done, and that way we might actually understand it. So 5 plus 16 is equal to 21. That's a 0. 26 plus 8 is equal to 34. And 4 plus 8 is equal to 12. That's an 8. 23. 34. 0. And 39 plus 16 is equal to 39 plus 16 is equal to 5, 1, and 55. And then you have your matrix here. So this is the same thing as AA squared. Now you can see that A squared A is this matrix, and this is A squared, 21, 0, 34, 12, 8, 23, 34, 0, 55. They are exactly the same thing. A squared is equal to A squared A. And I have done this one time before as well, and I got the same result using another matrix. So it seems that the result is going to be this way. Although, well, if you want to state that as a theorem or anything like that, you need to prove it. Okay, so now we know, and that is basically equal to A cube, right? That is actually equal to A cube. That is the same thing as A cube. And so now we know what A cube is, which is what we needed here. So I'm going to erase all of this. You don't need it really. Okay, so now since we know what A cube is, and we know what A squared is, and we know what A is, and so on and so forth, we can write this equation, and so the equation is A cube minus 6 times A squared plus 7 times A plus 2 times I is equal to, now A cube is this matrix, which is 21, 0, 34, 12, 8, 23, 34, 0, 55, and negative 6 times A squared. A squared is 508, 508, 508, and 245, 245, and 8013, 8013, this is 4, and plus 7 times A is equal to basically 102, 102, 021, 203, plus 2I, plus 2 times I, which is equal to 100, the same order, 010, 010, 001, 001. So and that is the same thing as we need to multiply these by these matrices. So 21, 21, 0, 34, 12, 8, 23, 34, 0, 55, now minus 6 times this matrix is 30, 0, 6 times is equal to 48, that's a 12, 24, 30, 48, 0, 6 times 13 is equal to 60 plus 18 is equal to 78, plus 7 times this matrix is equal to 7, 0, 14, 0, 14, 7, 14, 0, 21, plus 2 times this matrix is going to be 2, 0, 0, 0, 2, 0, 0, 0, 2, And if you add all of these matrices together, first you can add this one, this one, and this one, and then subtract. No, you cannot do that. You have to subtract this one from this one, and then add these two to whatever you get here. So I will add these, I will subtract this one from this one first. So 21 minus 30 is equal to -9. -9, 0 minus 0 is equal to 0. 34 minus 48 is equal to, so 48 and 34, 4, -14. And 12 minus 12 is equal to 0. 8 minus 24 is equal to 24. 8, 14, 16, -16. And 23 minus 30 is equal to -7. 34 minus 48 is equal to -14. 34 minus 48 is equal to -14. That's a 0. And 55 minus 78 is equal to 32, -23. And then you need to add this to those two matrices. So plus this matrix, plus this matrix, and this matrix. So 7, 0, 14, 0, 14, 7, and 14, 0, 21. This whole operation would be done by a computer probably in a microsecond, meaning 1/1,000,000th of a second or so. I mean, with the processors that we have today, 200,020,002. Okay, so now we need to add all of these together. So -9 plus 7 is equal to -2 plus 2 is equal to 0. 0 plus 0 plus 0 is equal to 0. -14 plus 14 plus 14 is equal to 0. 0, 0, 0 is 0. 2 plus 14 is equal to 16 plus -16 is 0. That is again a 0. That is again a 0. That is again a 0. So 23 -23 is 0, which means that this is actually equal to O, which means that basically a cube, -6 times a squared, plus 7 times a, plus 2i, is equal to O, considering the fact that A is equal to this matrix 1, 0, 2, 0, 2, 1, 2, 0, 3. That is what we wanted to show, right? Okay, so that was question number 16. That was question number 16. Question number 17. Question number 17, we have if A is equal to 3, -2, 4, -2, and I is equal to 1, 0, 0, 1, find K so that A squared is equal to KA minus 2I. Okay, so if A squared is equal to K times A minus 2 times I, That means that k times a is equal to, I can write over here, what I can write is that I can write a squared plus 2i is equal to k times a minus 2i plus 2i minus 2i plus 2i is o. And so I can write this as a squared plus 2i is equal to k times a plus o. And so I can write a squared plus 2i is equal to k times a. And then divide by k both sides, you will get, or divide by but we have not still done the concept of matrix division. I don't know how I'm supposed to solve this problem when I don't know how to divide. Because to calculate k, I have to divide by a, and then all of these matrices would be divided by a. So let's see, let's take a look at the solution here. Let's see what we have here. Okay, so before we get to this problem, I'll end this video here and we will continue this in the next video. Thank you.